what was used for this particular production, the algorithmic innovations, algorithmic changes. Okay, right. There are some changes that have been made from the previous submission to this. So this highlights some of them, and then the bug fixes. All right. So now for the model export, this model is ready to be published into Hugging Face. All right. So it's open source and can be used for further development. Then the change log, you can see the fine-tune model export, integration. Then the R2, the new ED and evaluation plots, the feature engineering bug fix. All right, and the reasons for the fix. Then here you have the algorithm changes carried from version 3, the stratified sampling and the likes, and of course others. Then the bug fixes carried. So there's still further improvement. Now, here is a screenshot of the previous mobile app that was developed. So this summarizes the entirety of this innovation. All right, so this is the updated version of Climate IQ. And as you can see, this is the dashboard, and under this, you have several menus, among which is the live KPI monitor. Then you have the critical alert at the top. Then, of course, you have the model trained, the value of the R squared, the critical notification, the run inference, and the export model, respectively. Then you can also see under the live KPI monitor the val test and R squared value, as well as the best RMSE value, and then the spatial RMSE value. Then, of course, the training PTS, the inference speed, which is 38 milliseconds. Then you have the task anomaly value. Then for the quick navigation, of course, you have the dashboard, the map, the forecast, the impact, the model, the downscaling, the live downscaling. Of course, then you have the alerts. Then further down this dashboard, you're going to see the task anomaly time series from 1980 to 2100. You can see it lined up, and then at the y-axis you have the temperature in degrees Celsius. Then of course you have the years. Then going down below, you see part of the algorithm that makes up this model, the fourfold CV performance RMSE, of course, then the assembled component weights as well. So let's really take a look at the map. This is the map. Here you have the NA-CORDEX regional map, the task temperatures, the precipitation. As you click on these menus, you see, and you click on the various boxes, colored boxes, you see the cells and the displaying of the temperature anomaly. All right, you can also view the detail, as it's going to give you options to export into CSV or as a picture, that's a PNG format. You have the metric, the value, the baseline, respectively. Then, of course, the precipitation too. It's a similar thing. You can also do the same thing and see the metrics, the value, the baseline, and of course, the alerts. Then, following this, you can also see the heat index, which similarly you can view the full analysis of the task anomaly, the precipitation, the heat index, the drought index, and the model R squared. Then finally, you have the drought index. So after this, you can also see the forecast. All right, this forecast is unique because it has all the multi-scenario projection from the double SP 1 all the way to double SP 5 to 8.5. So beneath this, you have the climate milestone table, which gives you the year, the scenario, the task anomaly, the sea level, precipitation change, then the risk levels as well. So following this is the impact. You can see the sector vulnerability assessment, the urban heat, the agriculture, the water resources, the public health, the infrastructure, the biodiversity, then the policy adoption timeline as well. You can see it broken down all the way from 2025 to 2100. All right, in years. Okay, so then following this impact, you have the model. These are the models. Of course, this is the real base of this model, the model that backs up this application, the Climate IQ application. You see the CNN LSTM architecture, the loss convergence, temperature importance, the full five-fold metrics. All right. So after this, you can see the downscaling. You can navigate and run live inference. Okay, downscaling inference where you can see the various colorations for the task output grid respectively. Then, of course, finally, you can see the alerts. Now, quickly, I want to just take you mobile aspect of it. All right, so this is the Climate IQ mobile edition. It's almost similar. It's the mirrored aspect of the web version. All right. So, and the updates has also been implemented here. And you can see the live KPI monitor, the quick access, where you have the map. Then, of course, you have the forecasts. Then, of course, then you have the impact, just as we've seen in the web version. All right. So then, following this, you have the model, as we rightly described. Then we also have the downscaling inference, which can be done by running the inference, and of course, you see the output respectively. Then the alerts and the export functionality, as well as the reports functionality. All right, so let's now quickly take a look at the Earth System Grid Federation climbing downscaling AI pipeline, which of course was fine-tuned with GraphCast model, and this is the updated version 4. All right, and you can see the link to the model, and of course the data that was trained on the NA-CORDEX, the CIMIP6, with the target accuracy of greater than or equals to 0.99, which is 99%. All right, so here we have the presentation agenda for this update. You have the project overview and purpose, higher local climate projections from global models. Then fine-tuned model architecture, which is built on the GraphCast, of course, and ready for downscaling head with Hugging Fix export. Then you have the data and split strategy, the NA-CORDEX CMIP6, and then the split, which is 40, 15, 15, 30. Now, following this is the algorithmic innovations from version 3 to 4. Then you have the evaluation metrics, then the ED and visualization suite, then the model checkpoints and exports. Let's now move to the next item. Here you have the project overview and purpose. The mission is to produce high resolution local climate projections from CORE's global model GCM slash RCM outputs to support urban planning, agriculture, and policy decision making. All right, so you have the model base, which is built on the Shema Sue GraphCast model on Hugging Face with the custom downscaling head added, fine-tuned on NA-CORDEX and CMIP6 NC climate files. All right, the targets, the accuracy target for the R squared is greater than or equals to 99%. All right, on a val test holdout split scenario. Then, of course, we also try as much as possible as a target to minimize the RMSE, the MAE, or maximize PSMR with strict four split pipeline. Train is 40%, val is 15, test is 15, holdout is 30 respectively. Then let's look at the model architecture. Like I previously said, this system is built on the NA-CORDEX, okay, and then with the NC files, and it is loaded and pre-processed. Then advanced feature engineering was implemented. Then the GraphCast um, model was used as the encoder, and of course the fine-tuning base. Then of course this downscaling aid took place, and then the assemble voting. Now, these are the engineered features. We have the latitude, longitude, elevation. Then you have the terrain roughness proxy, the coastal proximity index, the season sign course encoding. Then the source file. Of course, you have resolution flags, stratified temp range sampling, hetero stochastic NLL loss, N double L loss there. Then the log 1p target transform. Now let's look at the assembled components. You have the gradient boosting regressor, all right, the random forest regressor, the extra trees regressor, the ridge is linear baseline, neural downscaling head. So let's move to the next thing now, which is the data speak strategy. We have 40% train, 15% valuation, 15% test, and 30% holdout. For the train, we have stratified temp range sampling inverse frequency. It's a Hubbard NNL widths, spatial block CV, that's latitude strips. And for the validation, we have the hyperparameter search, early stopping, reduce LRO on Plato scheduler. Then, of course, you have the test, your bias performance measurement, the AI metrics versus the local mean baseline, which is strict, which has strict no leakage split. And finally, we have the holdout, which is 30%. The final model verification, uncertainty estimation, production readiness gates. Now, for the algorithmic innovations that has been recorded for version 3 to 4, you have the stratified temperature range sampling, which is inverse frequency Hubbard NNL loss weights. Then we remove the sign latitude, which R is roughly 0.9 there, reduce multicollinearity. Then the spatial block CV, that's latitude strip holdout for unbiased generation tests. All right. Then the local mean baseline predictor, all metrics reported baseline. Now, for the heteroscedastic Gaussian NL loss plus uncertainty log variable head was also modified, and the tail-weighted fine-tuning pass on samples with resolution greater than the omega threshold. Then the coastal proximity plus terrain roughness proxy features were added. Then, of course, finally, the variance stabilizing log 1p target transform gated by flag. So now we move to the bug fixes and the new requirements. For the bug fixes for version 1 to 4, we have the index error, the NA-CORDEX 2D latitude, longitude, mesh grid extraction. They reduce LR on plateau, verbose quark removed. That's Python, PyTorch, greater than equals to 2.2. Then the RMSE via NP uh, square root mean squared error, of course, was also adjusted. Then the NA-CORDEX fine resolution files loaded correctly. And the Torch API was also updated for PyTorch 2. GraphCast MP weights extracted for SVB1 initialization. Now, for the new requirements, the new features that was brought into this new version, we have that's the fine-tuned model export. All right. Now we can export the config.json, tokenizer files, model safe sensors, PyTorch model bin, assemble job live, scalar meta JSON. Then of course you have 12 comprehensive exploratory data analysis and evaluation plots. All right, dilation marginals, the KDE by season, resolution, terrain, coastal, scatter, pair plot, time decomposition, assemble, scatter, error by latitude, season, calibration, Taylor diagram, sensitivity. And of course, you have the feature importance bug fixed, which involve robust extraction from voting regressor via named estimators, dict plot type guards, averages importance across three base sub-models. So let's move to the next thing now, which is the evaluation metrics results. The results fairly still remain the same. We have R squared, which is greater than 99% for the val, test, and holder respectively. And the best RMSE, which the model was built on, is 0.029, which is, of course, very, very good. Then the best MAE here is a five-fold mean, also the same figure. Then the spatial block CV RMSE mean is 1.49. Then, of course, down below here, you can see the spatial block cross-validation RMSE by fold, the comparison of these two. So let's move to the next item, which is the exploratory data analysis suite. Here you can see, of course, all the updated EDAs from EDA 1 to EDA 12. I'll be leaving the link to the GitHub at the end of this video, or you can check it in the description on YouTube at the the description panel just below this video. All right, so let's look at the evaluation plot suite. These are part of the new plots that was actually added that was not previously there. So if you look at the GitHub again, I'm going to make a new an added directory in the GitHub, official GitHub of this particular software program for you to download and see each of these: the training history, the prediction versus actual, the residuals, generalization gap, the metric summary, the holdout deep dive, the CV scores, feature importance, the spatial error map, the accuracy versus resolution, the downscaling demo, the assemble models, the error by latitude, the error by season, the calibration curve, and of course the Taylor diagram. So the model checkpoint and HF export too, like I said previously, is ready to be pushed to Hugging Face. Now, these are things that we need to understand. Some of the key takeaways here is the production readiness of Climate AI. All right, this Climate IQ program. We have R squared as greater than equal to or equal to 99% on all held out splits. Right. Then you have 29 EDA plus evaluation plots. Then, of course, you have it ready for Hugging Face compatible export and for, of course, multiple application uses. Then the special block CV for robust generalization. So this is what the Earth System Grid Federation is about. The climbing downscaling pipeline version 4, GraphCast fine-tuned. I hope you enjoyed this. All right, so let's quickly take a look at this updated Earth System Grid Federation climate downscaling, all right, which was fine-tuned with GraphCast. This is the Earth System Federation Climate AI, and it's actually a downscaling pipeline that has been updated to version 4. Additionally, it's a high resolution local climate projections from the NA-CORDEX CHIMS global models using GraphCast fine-tuned with custom downscaling, lead assemble, urban planning, useful for urban planning, agriculture, and policy decision support. So down here you can see all the useful models. So right here you can see that this particular application was fine-tuned with GraphCast, all right? And then, of course, it's Hugging Face ready. So you can see that it is fine-tuned with GraphCast. So down here we have the accuracy for the val test holdout. You can see it's greater than or equals to 0.99. Rather, it is 99%. And then here you have the best RMSE at 0.029. Then over here, you have the best MAE. And here, of course, you have the total visualizations. Now, if you go further down, you see the data split strategy. The train is 40. And then, of course, you have the 15% as val. And then 15% as test. And then you have the holder, which is about 30%. Now, this is the model pipeline. You have the NC files being loaded and preprocessed, and feature engineered, then of course fine-tuned with GraphCast, and then of course the GraphCast fine-tunes and produce the model, the fine-tuned model, which of course contributes to the overall assemble. So these are the assemble weights. You can see that it's actually made of gradient boosting, random forests, extra trees, neural head, and the ridge. Then here you have the spatial block, CVMSC. Then the export status, the model safe sensors, and the likes. Now, if you go further down here, you see the simulated spatial temperature downscaling TAS. So you can actually um, regenerate. As you click this, you see it changes, and you see the overall impact of that simulation. Now, let's take a look at the fine-tuned model itself. It's made up of model tensors, PyTorch, binary files, assemble, job live, config, and the scalar, tokenizers, and of course the README. So if you now go, there is a very, very important part of this program that I want us to see, which is the running inference. Now, this is the inference, the live inference. You can actually change values like the latitude and the longitude, then the elevation, then of course the season itself. All right, here you have options where you see winter, spring, summer, and autumn respectively. And then of course we are working with the NA-CORDEX. There's also the option for the chimp 6. Then this is the kilometers. These are the distances that this particular app covers, and the options are listed in the drop down box. Now let's just randomize and see what goes on here. If you randomize and run inference, you see it processes, all right, and it gives us a particular value of the predicted output. So if you go down here, this is another very technical aspect of this code. You can actually place your select a size here. This is an editable box. Then here you have, of course, the areas it covers. It has, at the moment it focuses on North America. That's the NA Codex. But the global is also integratable. Okay, so we can actually use existing or other parts that is away from North American codex. You have the global there, then you have custom bonding box. All right, now here you have the types of files that this app can process. You have the NC files, the CSV, and then the ZAR. Now let's just quickly run the inference here and see what goes on. You see, it runs it and gives us the output, the breakdown output of the files that is under review. So that is all about the live inference. Then over here, you can see the architecture, the general architecture of this system, the model architecture, the feature engineering, the basic things that was used for feature engineering. Then down here, you have the downscaling code. This is an open source production. You have the training config, and then the dependencies, then the output parts. Let's look at the training. So these ones are just the training history and the graphs that produce this model. Then over here, you have the metrics, the key metrics that was used, the full metrics table, where you have the specific values for each of the metric, like the RMSE, the MAE, the Pearson R, the R squared, and the whole lot of them. You can see that this gives us an actual, not just visualization, but insight into the performance and evaluation of how well this model generalizes. And over here, you have the spatial CV fold RMSE. Then you have the Taylor diagram. All right, this is the Taylor diagram that is simulated here. The actual Taylor diagram, you can find it in the GitHub link that I've included with this particular report. So here you have the calibration curve and then the hybrid weight. Let's look at the EDA plots. All these can be gotten from the GitHub link, the evaluation plot. Now the algorithms, you can see we used what was used for this particular production, the algorithmic innovations, algorithmic changes. Okay, right, there are some changes that have been made from the previous submission to this. So this highlights some of them, and then the bug fixes. All right, so now for the model export, this model is ready to be published into Hugging Face. All right, so it's open source and can be used for further development. Then the change log, you can see the fine-tune model export integration. Then the R2, the new ED and evaluation plots, the feature engineering bug fix. All right, and the reasons for the fix. Then here you have the algorithmic changes carried from version 3, the stratified sampling and the likes, and of course others. Then the bug fixes carried. So there's still further improvement. Now, here is a screenshot of the previous mobile app that was developed. So this summarizes the entirety of this innovation.